Thank you very much.
Yes, Tushara, yes.
I got my power cut, so I think it's better to start the introduction soon and then hand over the audience to Dr. Mayuri. You are all welcome to the EUSL live webinar. This is the 10th in our series. We are focusing on circular economy, and today we have Dr. Mayuri Wijayasundara with us. I will quickly introduce her and hand over the session to her. Her topic is designing for a circular economy. Actually, I will briefly introduce Dr. Mayuri. Dr. Mayuri Wijayasundara is a management consultant and expert in strategy in enabling transition to a circular economy. She obtained her PhD from University of Melbourne, and she is a chartered management accountant of CIMA, UK. She worked in senior management level in transformative projects during her corporate career in resource recovery and building material industry. She was leading a research group in circular economy as an academic at Deakin University till end of 2011. And Dr. Mayuri currently works as a director of Anvarta, a consulting company providing insight, consultancy, and services and solution, helping organization to transition to a regenerative models. She is also a research active as an honorary fellow at Deakin University through PhD supervision, and also as an investigator for funded projects at Deakin University. So without taking much of your time, I would like to hand over the audience to Dr. Mayuri. Please commence your speech. Thank you very much.
Thank you, Tushara. I'm indeed glad to be here and happy that quite a few people still could make it. I think when you have to give a short introduction, you can't mention all the details, but one thing I want to sort of also let you know is that I'm a graduate of the University of Melbourne. I did chemical and process engineering, so I'm very much a sort of a product of the Sri Lankan university system as well. As I said, very glad to be here. I know it's sort of a challenging time for everybody in Sri Lanka, so thankful for making it to the session today. So I will share my screen. I hope you can see my screen now. Sorry. Can you see the screen now? Yes?
Yes, we can see.
Right, okay.
Yes.
Alrighty. So I'll get started. So as Tushara mentioned, I was an academic at Deakin University, actually till end of 2021, so probably up to the last year. And the area of circular economy is fairly new, and probably I think there's a lot of wide attention given to it in the last 10 years or so. And a lot of the work that I'm presenting you is very much informed by research, as well as now I'm into more of application through Anvarta, the organization that I'm operating now. But a lot of my sort of entry, as well as I would say the development of tools, insights, findings are and have been informed through research that I've done at Deakin University. So with that, I'll sort of start with a few slides about introduction to circular economy. Probably I think you would have had a few seminars talking about circular economy. I don't want to sort of go very much into detail, but if I'm to introduce the model, I mean, the word circular economy, as you can see, refers to an economic system. And a lot of the times this is associated with a lot of technical areas. So why is it still called an alternative economic model? Because the idea of it is actually to influence the way that how production, distribution, and consumption happens. So production, distribution, consumption in a sort of a larger context refers to an economic system. So to define a circular economy, one of the simplest definitions that I could find is an alternative economic model that focuses on regeneration of products, components, and materials to the highest utility and value. So each of these terms we can take one by one and talk about it a bit more in depth in the next couple of slides. So the easiest way to sort of understand or rather introduce a circular economy is to look back at what we're operating at the moment, which is a linear economy. So as I said, an economic model is basically you should refer to an economy in relation to a sort of a country. So anything that sort of is associated with production, distribution, and consumption, which generate economic value, are economic processes. So the three key economic processes associated with any economy is production, distribution, and consumption. And in a linear economy, when we want to produce, we have to extract resources. And at the same time, we produce, we distribute it through transporting it to the location of consumption. And post-consumption, we are ending up with waste. So if you take the left-hand side of the value chain and the right-hand side of the value chain, both create a degradation on the environment, because extracting resources is basically has a degenerating effect as well as disposal of waste. But at the same time, production and distribution also generates emissions. So if you kind of take every time sort of an economic output is produced, so an economic output could be a product, a service, what we typically could call as goods and services, which have economic value associated. So every time we have economic output created, there's a degenerating effect on the environment. And one thing that we also need to know about the linear economic model is that it's extractive, it's degenerative, but as an industrial model, it's very much focused on extracting at large scale, producing at large scale, using economies of scale to get advantage of cost. So a lot of the times when we do production, we do things that disturb the natural balance. So if you take too many things out of one place from the environment, it definitely contributes to losing of balance. So the extractive degenerative industrial model which basically functions on scale is such an economy. So the alternative one that we have is what we call a circular economy, which is a regenerative industrial model that circulates nutrients. We talk about this, how it happens in the next coming slides. But the idea is that when we produce an economic output through conducting production, distribution, and consumption, we have also designed the system that the resources going through the system can regenerate. So basically, we are not extracting resources and sending it to a graveyard. We have a mechanism in place that helps regeneration to happen as and when output generation happens. So how that is possible is by consciously designing it in the upstream. So what we call the upstream is what happens before consumption. So if you think of production and distribution, those are the key upstream processes. So this concept came into light through, this has a lot of other peripheral concepts associated, the principles of circular economy, but the core concept is it stems from a concept called cradle to cradle principle. And in the 70s, a German a chemist called Michael Braungart and a US American architect called William McDonough, they challenged the idea that doing less bad is not good, which means we talk about the concept of sustainability, where we do things in a certain way. We kind of we produce resources and we produce goods and services in a certain way, and we talk about sustainability. So sustainability comes as a concept where um, we kind of acknowledge and accept that we will continue to do things the same way, but sustainability is associated with reducing the harm. So what Michael Braungart and William McDonough said was that you can't do things the same way as you have been doing before and then talk about reducing environmental harm as the way of as your approach. Rather, think of an approach where every time you perform activity, every time you consume consumables, products, and goods and services, you, rather than apologizing for your footprint, you should be able to celebrate your footprint, which means you, rather than try to reduce harm, you should be designing the system to do good to the system. So how they sort of proposed to do it was by designing two distinctive cycles for resources to run. And the first one is called the biological cycle, where we design consciously that some of the resources that we use in goods and services, goods basically, it'll degrade naturally. So it'll basically, it'll go with it, it'll interact with the natural environment, and we design it to be interacting with the natural environment. And the other cycle is a technical cycle. So the other parts of the goods, products, components, and materials, we design them to be running in a technical cycle where they're designed for easy repurposing, recycling, upcycling of resources, recovery materials. So consciously, before we even produce something, we are kind of thinking and making a map of where would these resources end up at the end of life of the product, and then designing those pathways very consciously that recovery is possible in an effective and efficient manner. So on the right hand side, what you see is a watch. So in a linear economy, we can call it a watch and that's it. But in a circular economy, we go a few levels in depth. We will discuss about products. So the product is the watch. It's consisting of components, which are the other components that you see. And each component is made of a different type of a material, or sometimes a combination of materials. So for you to have this resources running in a distinctively in a biological cycle or a technical cycle, you need to design at the materials level and component level, and sometimes at product level. It has to be sort of done very consciously at the inception of a product design. And that's the core idea that forms the concept of circular economy. I thought I'll introduce a few more concepts which are associated to a circular economy. So because they all of them have an environmental proposition as a concept of circular economy. So the one such is that is low carbon economy. So I mean this has been there sort of throughout, where we I mean, especially with the impacts of climate change and other sort of degenerating effects, we talk about producing the same economic output with less greenhouse gas emissions. And that's the aim of a low carbon economy. And another concept is dematerialized economy, which means we achieve the same economic output by extracting less resources. So we either have more circulation or we have maximum resource use per resources produced. And the third concept is what we call the performance economy. So that is where you achieve optimum service performance from products. Once again, it's increasing utility, elongating life, and making sure that there are services created around the product to keep the product longer in use. And so all of these concepts play a part in what we call today as a circular economy, and they kind of they are integral, and they are sort of they're complementing each other in what we call a circular economy. But the primary idea of the circular economy, or what circular economy optimizes, is attempting to achieve regeneration of nutrients within economic processes. So I hope I gave an idea of the fundamentals and concepts associated. So going back to sort of describe a bit more about what circular economy is and what it is not. And I'll start with what it is not. So basically, if you try to achieve closed loop circulation of resources, so if you think that, okay, we have a product and we want this product to be coming back to making the same type of product. So if you take say a plastic bottle, we're using it right now, we want to recycle it to make it a plastic bottle. So that process of once it becomes a post-consumption waste, recovering it, repurposing it as a material, and producing the same output. So imagine there's a recycling process which consumes a very high level of energy and resources, chemicals, or and sometimes the recovery is costly or whatever. So achieving closed loop by putting additional resources and having more greenhouse gas emissions for repurposing is not the purpose of circular economy. It's not just recycling materials um, or trying to repurpose it as a trying to let the waste generate and repurpose it. So these can be part of what, when we move from a linear economy to a circular economy, these can be sort of steps in the middle, but that's not the core idea of a circular economy. Now, going back to what it is, it's designing the system to be regenerative very proactively, distributing and retrieving goods consciously. So a circular economy is not only about designing things, it's also about designing the system to distribute the cost to the consumer, and also making sure that the reverse pathway is accessible and activated. And it's about enabling recovery of nutrients post-consumption with purity. So we are, as I mentioned, we're thinking about two distinctive cycles and everything that is used in a product. So we have this concept where we consider what is valuable and what we pay money for to purchase as a product, and everything else as waste. But in a circular economy, we consider all of them as nutrients. So anything that goes to landfill or anything that gets dumped in a waste pile, and anything that you consume and pay a price and bring home, they're all materials and they are nutrients, they are valuable. So in a circular economy, we consider all of them as co-products or products. And what we try to do is to recover them and retrieve them with purity, so that the next economic life is something that can be designed quite effectively. So moving on to the strategies of a circular economy. So this is an expansion of the concept, which was initially introduced by Michael Braungart and William McDonough. So on the left-hand side, you see the biological cycle, where the two strategies are to regenerate goods, products, components, and materials designed either naturally or industrially. On the right-hand side is what we have, the industrial cycle, and there are 8 strategies that is identified that can be how this can be done. So some of the strategies relate to the product level, some relate to the component level, and some relate to the materials level. So I'll take an example and explain it a bit more. So the example that I'm taking here is a washing machine. So in a linear economy, when we want to buy clothes, we'll purchase a washing machine, and the transaction that we're thinking of it is purchasing it, using it, and disposing of it. So it's a fairly straightforward transaction, and we pay a price when we buy it. We probably discard it either for the town council to take, and in your case, let's say the Pradesh Sabha or any other sort of recycling store to take. In a circular economy, we think about washing clothes and a washing machine in a very different way. So washing machine as a product has constituent components, and components are made of materials. So the first 4 strategies are for the washing machine as a product. So we try to think, once the washing machine is produced, can we optimize its use by sharing? So having something like a communal access subscription. If you have like a set of washing machines where a lot of people can access and use, you're basically reducing the production of another one, and also you're making the maximum utility of the assets. And second one is maintain. So basically, rather than, so if your primary idea is to buy get access to services of washing. You don't need to maybe own a washing machine. So can you basically get access to a washing machine by paying a fee, where the washing machine ownership is with another person, with the manufacturer? And what is the advantage of this? So typically when we buy goods and throw it away, we as a consumer, you might not know all the components, materials, how to repurpose, how to recycle, how to upcycle, how to repair. So that information is basically not something that you um, you might have access to it, but you're not the expert of it. But if the manufacturer retains the ownership of the product and you just get access to the product with a certain financial model, the custodian of the resources would be the manufacturer, and the manufacturer has the information, network, ability, expertise to basically keep the product longer in use. So having a sort of a system to maintain the asset where a consumer accesses the services of the asset is another sort of aspect that we consider in circular economy. Third one is reuse. Once you own it, can we repair it, or rather we make it available for another cycle or another consumer for as a pre-loved item? Can we repair it as a product itself and help it run for a longer period of time? And 5 and 6 strategies on the industrial cycle are refurbish and remanufacture, which is related to components. So can we refurbish the components by selectively repairing some of the components? And for this to happen, the product components need to be designed to disassemble, to help repair, for remanufacturing. So you kind of need to think of how are we going to disassemble it at the end of the life cycle for 5 and 6 strategies to happen. And remanufacturing is you kind of replace a component or repair a component and replace it. 7 and 8 apply to materials. I hope you know the difference between upcycle and recycle. So recycle is the bottommost strategy where you let's say, for example, for a washing machine, you kind of crush it and then you try to recover plastics, iron, copper, like that. You kind of try to do it. So basically you have a commodity or a mixed material, which is very low value because everything is mixed in there and you can't actually utilize the full potential of the resources there. Upcycle, on the other hand, is a very aimed or targeted or measured sort of recycling. So for example, if you look at the washing machine, if the lid of the washing machine, you intend it to be a lid in the next cycle of a washing machine, you design it that way. And at the same time, you try to recover the lid that way. So you basically get the lid, you crush the lid, you make a material out of it, and you make another lid again. That is upcycling because it's very, it's getting the highest use of the material. It's very selected sort of a selected strategy for having I would say to claim or realize the best value of the material by having a purer stream. So if you kind of think of this type of strategies, they are the ones that kind of form what we call a circular economy. So I guess I'm coming to the topic where why design is so important. And I think you got an idea, a fair idea right now, why design is so important in a circular economy. And I sort of have a few things to share on a few examples and case studies. So one thing that I also sort of want to mention is the approach to transition. So it kind of looks very not something achievable or approachable, with all the sort of errors that we have in the current system. But if you kind of think of a more practical way to transition to that model from where we are in now, I'm sort of having this quote by Buckminster Fuller: you never change things by fighting this existing reality. You change something, you build a new model that makes the existing model obsolete. So when we think of transition to circular economy, the approach that we can take is that we don't say like, look, we don't do this from now, but rather we say that this is a new system that takes the approach that is sort of given by a circular economy, and we build the new system first and say that from this day, you're not using the old system, you're now in the new system. So that's the type of transition approach that I'm sort of promoting, as well as as a sort of a researcher in this area, as well as an academic in this area. So the approach that I'm taking is to transition to a new system. We need to replace parts of the old system with new alternatives, and developing those alternatives, testing them, getting them to the market, helping them get operationalized is what I sort of primarily work on. So it's something like this. We have a system like this, which is kind of not sustainable, not permanent, very difficult to drive forward. And what we need to do is to make it smooth by using the right tools, using the right approach, using the right thinking, using the right philosophy to think about resources. And the right that we want to have is something like this. So once again, talking about the transition approach, I have divided into two parts based on the economic processes. The left side is upstream, which is where we consciously design regenerative consumption. So for production, we are designing materials, components, and products to go in a certain pathway. And in distributing, we are thinking of how to retrieve products, components, and materials as much as possibly with the idea to regenerate. And once it passes the line, it's called downstream, which means we are having a product after consumption which has reached end of life. And typically in our linear economy, we call it a waste. And what we try to do then is to recover the resources and to repurpose it back to the economy. So if you kind of analyze both the parts of it separately, the upstream part, if you design the upstream part, it's proactive and it's very regenerative and it's very eco-effective, which means it's better value for money, it's better use of resources, it's sort of optimal design. If you try to influence the downstream part, especially in the linear economy that we are running, we are trying to do adjustments to recover and repurpose waste. And it's suboptimal. Our aim then should be to upcycle resources, and we cannot achieve the level of, optimal level that we achieve by proactively designing it. Right. So this is the approach that I was initially talking about, and I want to elaborate it a bit more here. So there's a publication that I'm doing on this, which is in progress. So when you think of the transition framework, as I mentioned, you're trying to move to a new system. So you develop alternatives, which could be alternative products, raw materials, supply chains, value chains. You also have the need to evaluate it against what you're doing currently now and make a decision. So it typically for an alternative to realize, it has to be financially viable, environmentally, it has to give value. And sometimes the alternatives cannot run just with the market mechanism, which means it's not profitable for people to uptake it as it is. So then you need to create market mechanisms for it to run. And sometimes government intervention or intervention of an economy is needed for that to happen. So the third part is operationalized, which means if that change involves a larger value chain or a supply chain, you want to create incentives and disincentives so that the players in the value chain, they have reasons to try it. And it requires redesign of the value chains, sometimes understanding how pieces are integrated as a sort of a larger mechanism. And fourth, we can produce and distribute products like this, but we also need to have the buy-in from the consumers. So introducing new choices of consumption, understanding and influencing buyer and consumer behavior so that the products that are made in line with circular economy principles are accepted is another part that we kind of need to work on. So the approach, once again, to summarize, you have there's no sort of, there's a very big systematic change, moving to a circular economy, and cannot be done in 1 year, cannot be done in 2 years. It'll take generations to do. But what we are doing is taking little iterative steps. So you kind of, if you have an idea and have mapped the alternatives, you have a roadmap that you have created, You design a system as much as possible as a framework in full. You developed small alternatives, you implement alternatives, you integrate alternatives, and you kind of make transition to a system in small and manageable cycles. And that's that sort of a, I would say, more practical and a realistic approach to take in thinking about such a big systematic change. So this is a framework that I've created for that as well, which helps the industry understand what needs to be done. So there's a part that we got to do in educating people and getting them on board, helping an organization understand the current position and the impacts, strategizing and creating a roadmap on what they could do, redesigning the system, measuring it, operationalizing it, integrating it, and reporting it. So this is basically for organizations who want to take that transition approach to move towards a different model. Alrighty, I'm coming to the core topic of designing for a circular economy. So how is the system to be designed? So I'll probably give an example of one of the key changes and draw your attention to rethinking why designing plays such an important role. So in a linear economy, as I think I mentioned this before when I talked about the 8 strategies, in a linear economy, when we sell goods, the responsibility of the good is transferred from the producer to the consumer. So we have this tendency where we buy something, we use it, and we throw it. So we, as consumers, we become custodian of the resource of a product, resources in a product for a shorter period of time, and our responsibility ends when it reaches end of life and the moment that we give it away. In a circular economy, what we are trying to create is an extended producer responsibility and product stewardship. So once again, getting the access to a product, but not the ownership, because we want to have the ownership remained with a party that can regenerate resources. So this is an example from Europe, where Philip sold light as a service. So this is a quote from the famous architect who says, Thomas Rao, who says, I told Philips, listen, I need so many hours of light in my premises every year. If you think you need a lamp or electricity or whatever, that's fine. But I want nothing to do with it. I'm not interested in the product, just the performance. I want to buy light and nothing else. So Philip basically went into selling lights, performance units as a service rather than selling light bulbs. So there are a couple of types of business models that are like that, aligned with the principles of circular economy. So what Philip did was the first one, result oriented. Performance product provided by the product is what is being sold. Ownership of the product, which is the bulb, is with the seller. You can have utility oriented model, which is cycle of use of a product. So the example I took with the washing machine, where you pay per cycle of wash, is similar to this. Use oriented, which means length of the product. So if you hire a laptop and use it for a certain period of time and give it back to the producer, that's this. And the last one, still in this one, the ownership is with the user, which means the moment you have a transaction, the ownership of the product becomes yours, but the manufacturer or the seller will sell the repair services with it. So it comes with like extended warranty, repair services, a replacement. I mean, typically the manufacturers give it for a certain period of time, and there are conditions attached. But having this more and more is encouraged or promoted in a circular economy. So this is about basically how do you design the system to make sure that the end of life products at end of life comes back in a manner that you are empowered, or you are sort of in a better position to use the resources of which I need effectively. Alrighty, we are going to the designing of products. So I've got 3 examples. One of designing of the system, designing of products, which I have a bit more in detail, and the last one is designing of the value chain. So designing of products, once again, coming back to the industrial sort of model of design. So typically in the industrial era, we were basically thinking of, we have been thinking of scaled up design, achieving economies of scale, extracting resources to a maximum level from where it is cheaper, getting labor as much as possible from where it's cheaper. Sometimes manufacturing products at 2 different locations, which gives the best cost advantage, and assembling it at a location which gives the best labor advantage for assembly, and shipping it to a country. So I mean, this is the sort of model that has been evolving as a with the foundation on the industrial era manufacturing. And this model basically has 3 main criteria in design: product performance, cost, and aesthetics. And when William McDonough and Michael Braungart talked about cradle to cradle concept, they challenged this paradigm by telling that that's not how you should think about products. You should think about economy, which means it should be competitive and feasible to manufacture. Ecology, it should be regenerative, and it should have lower environmental impact. Equity, it should create better distribution of resources without having the gap between the haves and have-nots sort of not to be that prominent. So equitable distribution, responsible relationship with the environment, and still being competitive to sell the products. So that's the concept that basically goes in line with circular economy. A lot of us still don't talk about equity with manufacturing or competitive businesses, but circular economy is a concept that, with the way it is designed, promotes equity and equitable distribution of resources. So Michael Braungart and William McDonough's concept evolved, and they basically formed a products innovation institute, and they undertake certification of products, and they have a certain criteria to qualify the product. So the 5 main criteria they use is material health, which is material is free of toxicity, it uses the right chemistry, right chemicals, and it's manufactured to be regenerative. So reutilization, the second aspect, covers the regenerative aspect. Renewable energy and carbon management, so you use as much as possible renewable energy, and then you produce it with lower amount of greenhouse gas emissions. Responsible use of water is the 4th. Social fairness is the 5th. So this criteria basically covers what you need to think about in going for a product design. And so products are sort of categorized as platinum, gold, silver, like that, based on this sort of evaluation, thinking for this evaluation. So when you think of product costing, so I'm coming to this aspect of costing because it's an integral part of design. So in a circular economy, we are seeing that more and more that we need to consider product design decision as integrated decisions. So earlier, if you think of the right-hand side of it, we want to do a financial aspect, which is material flow cost accounting, environmental aspect through carbon accounting, product performance through choice modeling. These are techniques. We kind of can consider isolated performance of a product in a design. But in going with the circular economy, more and more we are coming to this holistic thinking that not one aspect or better performance in one aspect cannot be taken as accepted when there are significant trade-offs in the other aspect. So we are moving more towards multi-criteria decisions and integrated decision making in evaluating products. I'll skip these two. Sorry, this one I can tell. This is an example of a research that we're doing on evaluating packaging material for carbonated beverages. So beverages like beer. So you can have aluminum cans, you can have glass bottles, you can have plastic bottles, and each of them have a different material characteristics, which is a third aspect, product performance. Each of them will have different type of environmental performance aspects. If you think of a life cycle assessment and evaluate and sort of measure it, they'll provide different values. Manufacturing costs could be different as well for each of these 3. So if you kind of want to have a more holistic decision about what's the best material to choose, and none of them will give you a very converging solution. It'll give you a solution where you know that one is better than the other in some aspects. So decisions like decision-making tools like analytical hierarchy process and multi-criteria decision analysis, those are some of the evaluation tools that we kind of use in research to evaluate and make decisions about those. So this is a publication that we are working on at the moment for submission. Okay, I thought it would be good to share with you an industry case study. So this is a case study on a packaging tool. The tool is called Prep Design, and it's basically innovated by this company called Green Chip, alongside with Planetark, which is not for profit, and a Australian Packaging Covenant Organization, which is an industry body. So the idea of this tool is that it helps the designers of packaging material to evaluate the packaging design before it's basically manufactured. So if you're, for example, if you're designing a plastic bottle with a plastic neck ring and it has a lid, plastic bottle is made of polypropylene, or I don't know, polyethylene, sorry, a PET bottle, PET plastic, and then you have a neck ring made of HDPE, and the top is made of metal, for example. So you then go to this tool and say that PET, the composition is this, HDPE, the composition is this, and you kind of input the tools, and the back end of the tool is basically mapped to the recycling capability of the country, and it gives you the idea whether it's recyclable with the current infrastructure or not. So what this tool does is basically informing the design by knowing what can be recyclable in the current system. So that's that concept we call in as a sort of a broad and generic concept in circular economy as co-design, which means designing together. And these are some of the tools and techniques and ideas to think about when we think of designing for a circular economy. Right, I'm going to the second topic, designing of value chains, where we kind of, this once again is talking about a suboptimal design, as I mentioned. So when we have waste generated and we want to repurpose waste back to an industrial process. So it could be that there's industrial waste generated by a certain industry, which can become a resource for another industry. So you have waste generated, there's a intermediary which could sort of get the waste and handle it and make it as a usable material. So there's a resource donor and a resource recipient. And what the resource recipient gets is a modified raw material or as a source of energy, and they can manufacture an alternative product. So in a circular economy, moving from now, which means moving from a linear economy, models like this are very, very common. So when we think about value chains like this, we are thinking of using of a raw material which is not extracted out of a quarry, for example, or a very sort of a standard and a predetermined source. Anything comes out of waste is very variable. It can be contaminated. It has varying quality. So there's a large variation sometimes you see in terms of flow and quantity as well as in quality. So managing them when you use it as a raw material of another standard process is basically a challenge. And so this is about some of the modeling that we do. We do supply demand modeling, matching modeling, as well as quality variation fluctuations modeling. So to determine what are the risks imposed on the supply chain with the use of such products in a sort of a larger value chain at a scaled up level. Alrighty, I think I've covered quite a bit, and I want to sort of end by making this sort of very obvious facts about a circular economy. I think I've sort of made an introduction. We talked about 3 types of areas that design makes play a crucial part. When we think about circular economy, it's a really broad, a broad systematic approach. It's it's not something that one company can do, or one player can do, or a sort of a recycling company can do. It's a broad systematic approach where a lot of players in the value chain need to get involved, and it requires collaboration. It requires multidisciplinary skills as well as specialized expertise. But once you sort of want to create it or co-create it with other people, the idea of a circular economy is to make the make resource use more sustainable, and as I mentioned, not to apologize for consuming resources, but to make it as a celebration, which means you do consume resources, but you have consciously thought of the redesign of a system that these resources are not ending up as waste, but as useful co-products for another one. So if you have this being implemented at industrial level, a, a range of professions have to come on board with there's sustainable leadership which kind of promotes the concept, but this is very much a business proposition which creates competitive advantage as much as it's an environmental proposition. So working with data and information, establishing collaborations, having that systems thinking, they're sort of key to make a very successful and effective transition. That's it from my side. I'm open for questions. Hello.
Hello. Yeah. Sorry. Thank you, Mayuri, for your very informative presentation. Let's see whether there are any questions for you in the chat area. You can put the questions in the chat area as well if it is difficult to speak up. Because Mayuri, you must be aware that we are having, so long power cuts in Sri Lanka.
Yes, and I think we have really good participation in terms of power cuts, and I'm grateful to the people who thankful to those who came. And
yes, unbelievable hours. Yes. So any questions you can type in the chat area as well. Once again. Yes, Dr. Jeevan. Yes, go ahead.
Thank you, Resha. I can go on speaking to you and without typing chat. Thank you, Mayuri. Very nice, very detailed presentation and excellent slides as well. Very informative and very nice to look at those sort of illustrations. And I have, do you hear me, right?
Yes, I do. Yes.
Okay, so my name is Jeevan, and actually I'm attending from Sweden. I work here at the KTH in Royal Institute of Technology in Sweden. I'm working with the energy field, and we are actually getting more and more into the circular economy aspects in all our education and applications. And Sweden is doing very great with recycling and the use of material and those perspectives. But my concern is to this movement about the circular economy, mostly going with the material based approaches, and then getting, we are designing to conservation of the material and the reduction of the material use and so on to serve the nature and serve the natural resources. But that also involved with, actually you addressed these words during your presentation, like one is the energy, the other one is the economical, the aspect where the labor cost and the human resource will be cheap and will be not cheap and so on. So this is very broad, absolutely, I understand this. But my question now is first thing that do you have any considerations about how the recycle or the circularity of the material or the circularity of the product cycle integrate with the energy cycle? Because if someone is asking you or asking a circular economy experts about energy cycle, they always have the example of a bioenergy cycle, starting with the biomass and use the wood for the heat generation and electricity, and then taking back and so on. But when it's combined with the product cycle and energy cycle, there will be oscillations between, like some cases from the energy wise that may not be profitable to do from the environmental perspective, not only the cost as well, the environment and other concerns. And in some cases where the labor is so expensive, and so this re-engineering or the rework of the products for the reuse can be really problematic compared to the other cases. So this sort of integrations probably is far ahead of the future to think, or you are already looking at those sort of aspects. This is just the broadening to the question, just to broadening the knowledge of this aspect.
Yeah, okay. I mean, it's a very interesting question and very interesting aspect of circular economy as well. So the way that we sort of a very simplified picture that we are currently sort of the approach that we are thinking about it. When circular economy addresses the resource part of a sort of a problem, the energy part is the other aspect of it. So it's like two sides of a coin. So anybody can sort of regenerate a material, but when you think of the balance between optimum resource use and optimum energy use, then that's where the I mean, sometimes they are not going in the same direction. So if you I mean, one example is if you think of a product like concrete, so you can basically you have a material, so you have product which is, let's say, concrete. You want to crush it and you want to recover the aggregates. So if you use thermal energy and you use like, you know, extensive amount of mechanical resources, mechanical sort of transformation, and you can get the aggregate at a very pure level, but then the cost of getting there is compromised because there's higher level of energy consumption. So the two things I'm sort of I mean, in the research work, I'm just sharing with you how we sort of address it, or how we sort of think about it. So one is that when there's energy consumption, once again, like the cradle to cradle approach, to what extent you're going for renewable energy is one aspect. And then when you do when you take the measurement aspect of two alternatives, so you have current way of doing things, you have another alternative way that you're proposing to do it, then one of the key things that we need to do is to do a life cycle assessment of the new product as a sort of a comparative assessment. So the life cycle assessment basically covers the I mean, the total life cycle, global warming potential, like the energy component of it is sort of covered. So that detailed piece of information has to inform the process of evaluating and comparing the alternative. But when you think of it as a optimization sort of a problem, so like the value chain modeling and all that we've sort of considered, unless you model the environmental effect with the amount of regeneration, you cannot actually get a true and you cannot achieve true regeneration which is effective for the environment. So my sort of how do I say, in summary, what I'm telling you is that regeneration at the cost of energy is not the optimal design, or rather it's still a suboptimal design. So trying to get back to where we started, to create a closed loop by spending energy, is not the idea of circular economy, but rather addressing it as an integral and an integrated problem, knowing that it might converge, it might not converge. If it doesn't converge, you have trade-offs, and then which one to choose, you kind of need to think of it as a sort of with a more systems thinking.
Absolutely, yes. I think, yeah. So it's a very good explanation. I think this will be mostly like the location oriented as well, like economy, and also what I mean. I think that the studies that you perform, and also many people performing on this topic, will probably lead to policy makers to identify and prioritize various material-based systems that has to be recycled. The landscape of energy is also very, very fast changing, and with the renewable energy, that will favor very much of these approaches. And so I understand, but it's a very broad and not yet find answers. If I may, for continue with the question, I would like to ask you. Sorry, Iresha, can I continue with?
Yes, of course, yes.
Sorry. Yeah. I mean, you gave a couple of examples like a washing machine case and so on, and also I really like the one that you showed, the beer can, aluminium, glass, and the plastic. So it's a point that we can discuss quite a lot. These are very, very. But my question now is, do you have any from Australia that very practical example, like some company working like example of okay, they are having this sort of approach for their product, and they are calling them back. And then this has been promoted by the government or some other organizations to carry it on. Because in Sweden, we have to pay when we are buying tires, we have to pay the recycle cost as well already. But I don't know how they are going to utilize it by myself. So that's what I am asking. In Australia, if you have any example from Australia, that will strengthen up our understanding. So that's my last question. Anyway, thank you very much.
Yeah, I mean, with tires, we have this mechanism as well where the producer paid upfront for sort of a recovery cost of the material. There's another example that I can tell you about a furniture manufacturing company, so furniture repair company. So there's this company which repairs furniture. And what they do is they get old furniture, disassemble the components and repair, and sometimes try to make a different furniture out of it. So when they come across, when the new design or the repair becomes challenging, they inform the producers that your design is actually not repairable or not repair friendly, or so that type of creating that sort of information loop is so effective. I mean, that's the same thing that was done with prep design, the tool that I was showing you, informing back the design that you have challenges with end of life management. So that's sort of yeah, I mean, I think great example that you that not a lot of people sort of do, or not a lot of organizations are thinking of. I mean, coming back to the tire example, the idea that I mean, one of the things that I'm researching on, one of the core things is that how do you basically introduce pricing as incentives or disincentives to create those mechanisms. So basically, if you want to introduce market incentives, taxes, subsidies, and sometimes if you want people to do things voluntarily, there's a sort of a limit that you can do. But the best incentive for moving from one system to another system or for behavior change comes through pricing. So effective, very effective, like carbon pricing. So using pricing to induce behavior change and induce moving to a new system is sort of one area sort of having sort of projects and specialized in. So that's, I think I would say in Australia, we're still a bit new on that area, but it's increasingly being sort of looked at and explored, and projects tried upon as well. Yeah.
Thank you very much. Thank you.
Thank you, Mayuri. There's another question in the chat area. It says, do major manufacturers follow their circular economy model to their product? That is the first question. And second one is, most of the consumer electronics devices are so integrated and designed for use and discard. On the other hand, repairing reuse of such products are costly. What is your opinion about this?
Yeah, I mean, major manufacturers, there are some initiatives, there's some interest, but not very much. There are companies like Patagonia. I mean, there are sort of few companies who are leading as frontiers in this area, who have thought about material redesign for a circular economy. And IKEA has shown some interest. For example, I mean, just some of the sort of more known companies that I'm sort of referring to. A lot of companies come across still, I think, being a relatively new area. I would say in Australia, they are kind of at the inception, but exploring solutions, sometimes tackling one area, but not as an integrated approach as a whole. It's quite new. Sorry, what was the second question about the electronics?
Yeah,
so electronics definitely is a sort of a really good example for designing for disassembly and designing for recovery, designing for recycling. Now, there could be an argument that when you do that, you, I mean, their production reduces, and their, how do I say, would they be happy to compromise profits because the amount of material sort of I mean, the amount of products that they can give is sort of reducing. But the beauty of the model, I guess, is that the circular economy is not about reducing revenue generation. You are using the same amount of nutrients or resources, and you're making multiple cycles of revenue through one cycle of resources. So if you, for example, have a phone which can be used in multiple cycles to repair, you can either sell it through a subscription model, or you can sell it to a customer, get the product back, repair, and give it to another customer. So with one cycle of resources coming in, you are making multiple cycles of revenue generation. So this is kind of identified as a model. I mean, that's the name that I use for my blog. Is the best way to grow infinitely in a finite world of resources. Resources are finite in the earth. We have so it's limited. We can't have more. We have to manage with what we have, but we can actually make the growth, accelerated growth, with the same amount of resources by conscious use and design of it. So I'm coming back to the electronics example. It's this value proposition is sort of not, I don't think it's 100% identified. There's an incentive for metal recovery and metal repurposing much more now, especially with the renewable energy transition. And I mean, world has limited metal resources. But I think there's a lot of work still to be done by large scale manufacturers.
There's one request as well. Could you please share the slides with us?
Okay.
Yeah.
Iresa, Janaka here. Can I ask
Yes,
one more
Janaka, go ahead, please. Yes,
Yes,
Janaka.
Yes, thanks, Mayuri. That's a wonderful presentation.
Thank you. You got muted. Yeah, you're muted.
Janaka, where are you? Yeah, there he is. Yes. Janaka.
Can you hear me?
Yes, I can.
Yes.
Yeah.
Yes, actually, I am Chanaka Ratnakumara, the Chief Operating Officer from Vijay Newspapers Limited, Sri Lanka. You know that Vijay Newspapers Limited, we have been practicing a lot of the best practices, sustainable practices for last couple of years, maybe around 10 years. As you mentioned, you know, we introduced very recently we implemented ISO 14051, that is the material flow cost accounting, and also we are certified 14,001, ISO 50,001, responsible care practices and circular, you know, that the industrial symbiosis practices. There are a lot of sustainable practices that we have been, you know, practicing. Very recently, we started, as you mentioned, you know, that we sell newspapers, right? So our next target is to recollect that newspapers by giving the discount to the customers or readers. You know, the today paper we can collect back tomorrow. Then when he you know, comes to buy the newspaper, then we give him about 20% or 30% discount. So then we can collect it back, and what we are going to do, we are going to send it to the manufacturer, the paper manufacturer, to recycle it. Now we have already converted our operation actually to the 100% recycled and SC certified products. So energy wise, we have already, you know, our energy bill was about 8 million Sri Lankan rupees in 2013. By last year, we were able to reduce it to about 2.8 million, and 100% we went with the solar. Now our electricity bill cost is just 800,000 rupees, 8 lakhs. We reduced from 8 million to 8 lakhs within the last 5 to 7 years. So our next target is to go with the net zero carbon by 2024. We are going to actually introduce one more solar system. Then after by end of the next year, we'll be able to generate our own energy from our own renewable systems. So in that, my question is actually, you know, addition to that, on the other hand, we have 3 separate wastewater treatment plant. Even with our wastewater, we treat and we reuse for the building cooling system, the rooftop, through the sprinklers to cool the buildings. Then we, you know, that heat load is reduced. Then our air conditioned load consumption is also reduced. That's how we have designed the building according to the green, you know, the building practices. So my question is, you know, that when we are doing and practicing like that, how we can say we are in the circular economy principles, and we are in the what scale we are, how we can say that we can use that word we are practicing circular economy, or what do you think that where do we, that do you think that we need to add some advanced system to move to the circular economy other than this? So any can you just give me some idea about our procedures?
Yeah, I mean, the plan that you mentioned about going to net zero. So net zero will give you an idea of or rather communicate. It'll help you communicate better about your footprint as a whole. So you kind of say that scope 1 and 2 and 3 emissions are like this, and you have mitigation pathways like that. For
Yes.
circular economy, for measurement of that, there are frameworks and metrics that are coming up very, I mean, they're quite new. For example, if you've heard of Global Reporting Initiative, it's a global reporting body on reporting environmental sort of performance and sustainable ESG sort of altogether, sustainability and environmental, social, and governance sort of reporting. They are increasingly sort of incorporating the stewardship aspect of products, as well as the regenerative aspect of products into their reporting mechanism. So it's sort of, I think they're changing quite a bit now to report on circular economy. So a few things that you could do is that if you're, I don't know whether your company is undertaking GRI or sort of a similar sort of reporting, there are some disclosure requirements on voluntary disclosures on sort of telling about your waste and management and practices. So having I mean, when you do reporting, making sure that you mention that you sort of track the entire value chain is sort of one aspect. So getting into those reporting mechanisms to sort of show your strengths in that. Matrix wise, there's the Ellen MacArthur Foundation has a circular economy matrix, which has been released, and a few other sort of organizations are World Business Council for Sustainable Development recently had a release of circular economy measurement sort of framework. So trying to sort of adopt one of them, and it sort of helps you get certified. So what I mentioned as cradle to cradle, it's a bit expensive to sort of get the certification, but it's kind of considered in this world as one of the ultimate certificates. And the other thing is that you asked me about improvements. Look, there's always improvements that you can do once you start measuring and seeing the numbers. It sort of gives a really good idea on what else can be best tackled. I think retrieving the newspapers and recycling it maximum is a great idea. If you kind of look at the footprint of newspapers, there's paper, there's printing, there's carbon. Sorry, there's ink. I have the feeling that ink is a sort of usually a bit of a challenging material when it comes to footprint. So, I mean, one of the examples given by Michael Braungart, I'm just sharing, I'm not telling that you should do this. So he was suggesting that you should basically.
We have been, trying now last 2 years, we are trying to replace ink with the vegetable-based oil, ink, soya-based, but unfortunately still it is not commercialized. We tried that sample with the manufacturer in overseas. So they redesigned and sent the product to us, but we tried it, but still the problem is not commercialized. So it is quite expensive compared with the, the traditional products. So it's not financially liable. That's the actual issue. That's why we have not moved to that. But anyway, we'll see. It's economy. It is designed for an entire, that economic system. Then definitely we can move to that side. Other than that, almost we have already converted our pre-paste operation to the chemical free. Now we don't have machineries and all. We design with we purchase and reinstall with the free chemical. That means we don't use water or chemical like that. Then previously we had to use some environmental hazardous chemical, and after that we replaced with the environmental friendly chemical from 2018. Now we are moving with the zero chemical in the pre-paste operation in the newspaper.
Yeah, that's I mean, really sounds really good. Because distribution might be a big part of your operation. Optimizing that is the other part that, all this, what I'm telling, have business reasons as well for you, because the better the optimized operation of distribution is better for you. So probably you'd have looked at it. But yeah, I'm just trying to break it down to a few pieces that to sort of help you think about it. I think you've tackled quite a bit and can be proud of it.
Yeah, thank you, Anvarta. Anyway, that can you just share that what is the institution that told that about the scale, what is the circular economy principle scale who are developing it? So then I can follow up at we will try to move to that side further.
Yeah, cool. Would you mind sending me an email? Then I'll have your email address and I can share it with you.
Okay, thank you very much. Yeah.
Thank you.
Okay, let's see whether there are any, we can entertain. Yes, we got time for a couple of questions. Let's see whether there are any other questions from the audience. It seems there are no more questions. So on behalf of Sri Lanka Association for the Advancement of Science / Section C and Department of Mechanical Engineering, the Open University of Sri Lanka and EUSL-Energy project, I would like to thank today's speaker, Mayuri Wijayasundara. Thank you very much, Mayuri, so giving us the opportunity to listen to you, and hope you'll be working with us regarding this circular economy business throughout our project as well, right? Thank you so much. And I would like to thank the participants as well. Thank you very much for joining with us, and have a pleasant day. Thank you.
Thank you. I've got a very engaging audience in the middle of all the challenges that you're having. So thank you for participating and being there. Appreciate that. Thank you for organizing, Iresha and Tushara and Ruchira. Yes.
Yeah. Thank you, Mayuri. Thank you. See you.
Thank you. Bye.
Thank you, Mayuri. Thank you very much.
Thank you, Jivan.